Okay, guys, so we're moving on to the section 8-2 and 8-3 test review. So remember, section 8-2 was really explaining what hypothesis tests are, and then it talked about the type 1 and type 2 errors. So this first problem kind of focuses on that. Again, these problems are worth 3 bonus points if you turn them in by Wednesday the 8th. So number 1 says, as a construction engineer for a city, you are responsible for ensuring that the company that is providing gravel for a new road puts as much gravel in each truckload as they claim. So if they claim to bring, I don't know, 40 meters cubed, then you want to make sure that they actually have that much in their truckload. So you plan to measure the volume of gravel in an SRS. Remember, SRS stands for simple random sample, so that's good. Simple random sample of 25 trucks. I'm already thinking, there's my sample size, to determine if the company is delivering less gravel. Okay, so that means you're suspicious that they're delivering less gravel. I'm already thinking that's probably going to be my alternative, that the amount of gravel is less than they say per truckload than they claim. Oh, on average. Of course, it's an average because we're talking about a hypothesis test. And each truckload is supposed to have 20 meters cubed of gravel. That's actually the claim that they're talking about. Oops. Their claim is 20 meters cubed. That's how much it's supposed to have. You decide to use alpha equals 0.05. That's important, of course, as well. Okay, so first it says state appropriate hypotheses for performing a hypothesis test. So my hypotheses are always H0 and H1, my null and my alternative. So they always fit that parameter is equal to the null value, and the parameter is in some way not equal to the null value. So let's give an example of that. Let's look at trying to find the right notes. I'm going to look at the IS number 16 notes, and I'm going to come to section 8-2 big ideas. This is on the back of the first page. Here we go. Null and alternative. We either choose the parameter mu or p, whichever one it is in our case, is equal to the claimed value or the null value. That's the null hypothesis. The alternative will either be not equal to, less than, or greater than, depending on the context, null value. So let's see, it was on average, right? This is not a proportion. We're not talking about the number of people who said yes or no, or the number of things that qualify for this characteristic or not. We are talking about an amount, which means we're going to be taking averages. So the average truckload is what we're talking about. We'll have a mu here as our parameter. Mu. And then the null is always equal to. So mu is equal to their claim. Their claim is 20 meters cubed per truckload. So the average then, if they claim to have 20 meters cubed per truckload, the average should come out to 20 meters cubed. If they have a little bit less on one truckload, that's okay, as long as they have a little bit more on another one, and it averages out to 20. So then the alternative, again, now you're thinking that they have less gravel per truckload than they claim on average. So you're claiming that mu is less than 20 meters cubed. Okay, so null and alternative. Some of you are asking why you would use less than instead of just not equal to. Well, we use not equal to if we were just trying to test if this was different. If we didn't know if it was going to be less or more and we're interested in either one. Here, we're really just interested in less than. And of course, I always need to state what mu stands for. So this will be my true mean, let's see, amount of gravel per truckload. Okay, so now it says describe what a type 1 error would be in this context. So remember, a type 1 error, I always kind of think of it as the first hypothesis is true, type 1, first hypothesis. So that would be that the null hypothesis is true, but you reject it. Right? If the null is true, we should not be rejecting it. So if we do reject it, then we've made a mistake whenever the null is true. So a type 1 error would be if the true average, actually, instead of saying average, I'm going to say mean, like we did in our parameter up here. The true mean gravel per truckload was actually 20 meters cubed, but we decide to reject the null, right? Remember, again, if the null is true, we don't want to reject it. So if we did reject it, then we made a mistake. But we decide to reject the null. This would be, again, if our p-value ends up being less than alpha. Remember, the p-value can be less than alpha a certain percentage of the time. So it's possible to make a mistake in the decision as far as like what's actually the truth without having made a mistake in the process of the hypothesis test. Okay, so what? But we decide to reject the null, which means, and reject the null, I don't need a comma there, and thought, if we reject the null, that means we thought the alternative was true. So we thought the mean was less than 20 meters cubed. Okay, so it says, what is the probability of making a type 1 error when performing this test? Again, this would happen when our p-value is less than alpha. So we think that this probability is so low that the assumption of the null must not be true, but alpha percent of the time, it actually is true. So the probability is alpha equal to 0.05, which again, it was stated up here in the problem, is that probability. So I could write that out again. I'm not going to this time. In general, on your test, you should answer in full sentences. So then D is to describe what a type 2 error would be in this context. So a type 2 error is the opposite. It's the second hypothesis is true and you make a mistake. So if the true mean really is less than 20 meters cubed, but you make a mistake, you don't reject the null, you fail to reject the null, and you think that the mean really could be 20 meters cubed. So a type 2 error would be if the true mean really was less than 20 meters cubed. Okay, so again, if the alternative is true, but we fail to reject the null and think the average is 20 meters cubed. So that's not exactly right. We're not proving the average if we fail to reject the null, but we don't have evidence against that average of 20 meters cubed. Okay, so the last question is which error, a type 1 or type 2, is a more serious problem for the city? And explain. Okay, so let's think. If we have a type 1 error, the true mean, we really are getting 20 meters cubed, but we think that we're getting less than that. Well, if that's the case, then we are probably telling the company that they need to provide more gravel per truckload, right? Because we think that they're not providing enough. And so, I don't know, maybe you have to have a discussion with the company. If you are, making that decision wrong, you're just getting a little bit extra gravel. Not the end of the world, right? On the other hand, if we have a type 2 error, we think that we're getting enough, right? We think that the average is 20 meters cubed, but in reality, it's actually less. So I think this is the bigger problem, because if we think we're getting enough and we're not, then we're paying for less than we should be, we're paying for a certain amount and getting less than we are expecting. So let's see that. A type 2 error would be more serious. And again, we're talking about more serious for the city. For the trucking company or for the gravel company, they would probably prefer a type 1 error, right? They prefer for us, a type 1 error would be more serious for them, I should say. That's if we think that they're not providing us enough, but they really are. That's pretty serious for them. On the other hand, for the city, it's more serious if we think we're getting enough and we aren't. So a type 2 error would be more serious because the city would be shorted on gravel and thus overpaying, which we never want the city to be doing with our tax dollars. Okay, all right, so that is it for the type 1 and 2 errors. I'm going to make another video for the question on the back, actually doing a hypothesis test.